Yeah, I think we are live now, and if we are going to solve some integrals in this video. Yeah, so basically, continuing the past traditions in this channel, we are solving integral B problems from 2010 to 2023. We have already done for 2010, 2011, and 2012. Now it's time for 2013 qualifier test. So I already have the problems and solutions ready. Yeah, and I think it's all visible now, and yeah, now I can begin solving the problems. So let's begin with this problem. Whiteboard. Okay. For this problem, we can first use the property of logarithms, and that gives us 2 times log x minus, if you use again property of log, this can be broken down. 2 times x can be 2 log 2 minus 2 log x, and then dx. 2 log x can be cancelled out. That gives us minus 2 log 2 dx. Now this is just minus log 4 is a constant. 2 can go here and become exponent, and we will just have x. So plus c. The answer is minus x log 4 plus c. Yeah, that's the answer. Now if we check it, if we check the answer, there's minus x log 4 plus c. Yeah. Now let's go to next problem. That involves modulus. Yeah. So basically, if it involves modulus, it's necessary to know the definition of modulus. Yeah. The definition of modulus is something like this. Okay. Now for this, the definition of modulus is it's minus x for x less than 0, and it's plus x for x greater than equals to 0. So this becomes integral from minus 1 to 0 of e to the power minus x. Yeah, for this range, this will be minus x, and from 0 to 3, it will be plus x dx. Now this will be e to the power minus x by minus 1 from minus 1 to 0, and e to the power x from 0 to 3. Yeah. Now when this is 0, we will have e to the power 0 by minus 1, and then minus minus plus e to the power 1. Yeah. Yeah. And then the next is e cube minus e to the power 0 is 1. So you can minus 1 plus e cube minus 1. So this is e cube plus e minus 2. This is the answer. And if you take the answer, this is e cube plus e minus 2. Yeah, that's the right answer. Let's go to next problem. This problem seems kind of complicated, but it actually is not. This problem though seems complicated, this actually is not, because you can notice that if this be v and if this is u, this is just u dash, and this is just b dash, and this is b square. So it's in the form v u dash, that is derivative of u, minus u v dash derivative of v by v square. So this is just d dx of u by v. Yeah, this is just quotient rule. So this can be written as d dx of sine x by log x, and we also have a dx over here. You can cancel the dx, and this gives us sine x by log x as the answer, plus c. Let's check the answer. Yeah. Let's go to next problem. For this problem, You can notice that this is 3C0, this is 3C1, this is 3C2, this is 3C3. So it's actually a binomial expansion, you know, and that is of x minus 1 whole cube dx. Now this is easy, use just the normal integration techniques. That gives us power 4 by 4 from 1 to 11. That gives us 10 to the power 4 by 4 minus 0. So that gives us 1, 0, 0, 0, and another 0, yeah, 4 zeros by 4. So there's 25, 0, 0. So 2500 is the answer, yeah. Let's check 2500. Let's go to next problem. This one. Now for this problem, first of all, it's necessary to remove the coefficient of x. If we do that, we will have root 3 times root under 4 minus x square. Yeah, we can take root 3 out of the integral sign since it's a constant, and the integral is from 0 to 2 square minus x square. Now if we try to plot the graph of root under 2 square minus x square, it will be something like this. This is actually be a quarter circle, and I want you to know why. Please explore on your own, like why this is a quarter circle, and it crosses at exactly 2. Yeah, the points of limits. It starts at 0 and intersects at 2, which are our limits, and this is also 2. Yeah, so this is basically a quarter circle with radius 2. Which is why its area will be pi r square by 4. And r is 2 over here, so there's pi times 4 square by 4. Sorry, pi times 2 square by 4, and that's pi. Yeah, and so that's pi. So integral from 0 to 2, this area is actually equals to pi. So now this is root 3, and this area from 0 to 2, this is pi. So answer is root 3 pi. Yeah. Now let's check. This is root 3 pi. Yeah. Let's go to the next problem. This problem involves odd even function. Yeah. If you are already familiar with odd even functions, that's a good thing. Or else, I will also share something about it. So basically, odd functions are those functions. If f of x can be odd function, if f of minus x is actually equals to minus f of x. In that case, the graph will be symmetric about origin. Let's say if it goes something like this, then it will go something like this. Is it? Yeah, but it's not a function right now. It will be something like this. Yeah, something like this. It's a symmetric about origin such that this area will be equals to, it should cross over here, this area. So these two area will actually be equal if this is odd function and it satisfies f of minus x equals to minus f of x. This actually means that for negative x values, the height is just in negative. So height is just negative. For negative x values, height is negative, and over here for positive values, it's positive. Yeah. So since these two are equal by this definition of odd function, so if we are going from some point minus a to some point plus a, both area will be equal, so they cross out and the integral will be 0. So for odd function, in symmetric domain from minus a to a, the area will be 0. Yeah, so that's one thing. And yeah, now let's try to solve this. First of all, let us put this as y. Yeah, and this also as y. Let me try to increase my pencil size, I guess. Okay, fine. Now if you put this as y, y equals to x minus 3 implies x equals to y plus 3 and dx equals to dy. Now since y is x minus 3, this will be from minus 3 to 3. X will be y plus 3 plus x minus 3 is y plus this is sine y, and dx will be dy. Now this is just y plus 3 whole square by 2, And these functions are odd functions. Yeah, y to the power 7 is odd function because f of minus x, if you look at f of minus x, that will be minus x to the power 7, and minus 1 to the power 7 is just minus, so minus 1 times x to the power 7, and this is f of x, so minus f of x. So since this is odd function, in symmetric domain its integral will just be 0, and sin y is also odd function. You can check that sine of minus x is, of course we know that it's minus sin x. Sin x is also odd function, so in symmetric domain its integral will be 0. Now this from minus 3 to 3, and that will be 3 plus 3 6 square by 2 plus, sorry, minus, and when you put minus 3 it's 0, so that's 36 by 2, that's 18. 36 by 2 is 18, yes, right. Now 36 by 2 is 18. Let's check the answer. 18. Let's move to next problem. Up to now I think the problems are easy and we do have two views. Are our viewers engaging? No, they are not. But still we do have two views, that's nice. And concurrent viewers with 130, nice. Now let's go with this problem. Okay. So for this problem, we know that this is the standard formula. We know sec square theta minus tan square theta is equals to 1. So sec square theta is equals to 1 plus tan square theta. So sec theta is equals to root under 1 plus tan square theta. And so this is sin x times sec x dx. And now this is sec x is 1 by cos x. So sin x by cos x is just tan x. And we all know the integral of tan x, that's just ln of sec x. Yeah. And that's plus c. That's the answer. Let's check the answer. Ln of sec x. Yeah, it's ln of sec x actually. Because if you take minus 1 to the power of cos x, that will be cos x to the power minus 1, which is 1 by cos x sec x. That's the answer. Let's go to this problem. This problem seems kind of complicated at first, but if we do some factorization, it's actually pretty easy. Yeah, let's see how. So in this problem, x cube common from the first, that gives us x square minus 1, and 1 common, x square minus 1. And from second, we can take x cube common, gives us x minus 1, plus 1 common, x minus 1. Now, we will have integral of x square minus 1 x cube plus 1 by, this is x minus 1 x cube plus 1 dx. Yeah, now this cancels out. Yeah, and now x square minus 1 is just x minus 1 x plus 1 by x minus 1 dx. X minus 1 cancels out, so this is actually x plus 1 whole square by 2 plus c. That's the answer. This one has just some factorization techniques and nothing more. And yeah, this is the answer. It wasn't that hard actually. Yeah, and this answer is kind of different. Yeah, let's try to prove this answer. Now if we expand it, it will be x square plus 2x plus 1 by 2 plus c. Now this is x square by 2, yeah, plus x plus 1 by 2 plus c is just c dash. This is the answer. X square by 2 plus x plus c dash. So 2 plus, yeah. Let's go to the next problem. Okay, so this problem. Okay, so how do we deal with this problem? So basically we can use integration by parts. Let this be u, and over here let 1 be v. Let 1 be in the product. Now we have log x, and integral of 1 is just x minus integral of, and the derivative of log x is 1 by x, integral of 1 is x dx. This cancels out, which gives us x log x minus integral of 1 is x from 0 to 1. So this is x log x. So now we need to find out limit x tends to 1 for x. It's easy. We don't need to find out limit. I thought if it was limit x tends to 0 for x log x, then we need to find out limit. Why? Because this goes to 0, this goes to minus infinity. So it's kind of indeterminate form. So now in this case, what we can do is, we can basically change it to this form, log x by 1 by x. Now in this case, it's actually infinity by infinity form. Yeah. Now in this case, we can use L'Hopital's rule, and then we can just differentiate. This gives us 1 by x by minus 1 by x square. Yeah. Now that is minus x. So now if substitute 0, that will be minus 0, which is 0. So this limit is actually equals to 0. And we will need that. Yeah. First of all, 1 log 1 is just 0, minus 1, 1, minus 0 log 0. We found that to be 0, minus here 0. The answer is actually minus 1. Yeah, that's the answer. It's already there. It's better if I directly bring with the answer, I guess. Yeah, because I felt easier just now. Now let's solve this other problem. First of all, let's simplify this negative power. That gives us e to the power x by e to the power x minus 1. Yeah. Now if you substitute this as y, we will have dy equals to e to the power x dx, which is there in the numerator. So this is just dy by y, which is ln of y plus c, and y is e to the power x minus 1. So ln of e to the power x minus 1 plus c. This is the answer. Yeah. But here it's different. But it doesn't matter. Do you know why? Because I actually cannot write this as well. Because if the value of x is, let's say, minus 1, in that case, this will be less than 0. So, but for log, it always should be greater than 0. Yeah, it should not be negative. So that's why I actually have to give this modulus symbol, and with modulus symbol, like both of them are actually same, ln of 1 minus e to the power x. Yeah, so that's the matter actually. Yeah, it's actually correct then. Now let's go to the next problem. This problem it's somewhat, we will use beta gamma function to make it easier for this problem. You can use alternatives using integration by parts or other techniques like that. For this problem, we have f of x equals to sin square x cos square x. Yeah. Now for this, even if it's pi by 2 minus x or pi by 2 plus x, both of these values are going to be same, isn't it? This will be cos square x, and this is minus sin x, but it's squared, so sin square x. See, it's same. Again, for other as well, it's just cos square x, and this is sin square x. Oh no, in this case, this was not minus sin x. I told it wrong. This was sin x in this case, but in this, we would have got first minus sin x and then squared, so that again be sin square x. Anyways, what I need to tell is from this, both of these functions will have same y value. The graph will not be like this though, but the y value, if this is let's say pi by 2, if this is pi by 2, the y value in both the directions will just be same. That means this is pi, let's say this is pi and this is 0. So this area and this area are going to be same. So this can be told as 2 times integral from 0 to pi by 2 of sine square x cos square x. Now we can use beta gamma function. Beta gamma function says that if it's from 0 to pi by 2 of sine to the power px cos to the power qx dx, this will be actually equals to beta of p plus 1 by 2 q plus 1 by 2 by 2. Then this will be 2 times, we have beta of 3 by 2 comma this is 3 by 2 and by 2. Yeah, 2 cancels out and we have gamma 3 by 2 by gamma 6 by 2. Actually beta AB is equals to gamma A, gamma B, gamma A plus P. So gamma 6 by 2 is gamma 3. Now this is gamma 3 by 2 is 1 by 2 times gamma 1 by 2 is square root of pi. Again this is 1 by 2 times gamma 1 by 2 is square root of pi, and gamma 3 is just 2. So this is pi by 8 as we have here. This was just an application of gamma function and observation of graphs. Yeah, the symmetricity, such things. Now let's go to problem 12. I hope these are not that hard problem. I hope you are feeling them easy. Yeah, you should not feel hard, because if you feel hard, then there will be trouble. Okay, now for this problem, we can first try to simplify this argument in sign. So let y be that, and then dy will be pi times 1 by 2 root x times dx. So 2 dy will be pi by root x dx, and this is already given over here, so that simplifies our problem a lot. Yeah, and our this boundaries will be pi root x. So this is pi, this is 21, square root of 41 is 21. Yeah, 21 pi, and this is sine y, and pi by root x dx is 2 dy. So we have 2 times integral of sine y is minus cos y from pi to 21 pi. So we have 2 times. Now for this problem, how do we solve this? Yeah, now minus cos y of 21 pi. At 21 pi, this is an odd number. Yeah, and for odd number, in this side we have 4n plus 1, but here we have 4n plus 3. Yeah, and over here we have 4n plus 2, over here we have 4n. Now 21 lies in 4n plus 1. Yeah, so this, in this our cos value will just be, this is 4n plus 1 pi. Is it 4n plus 1 pi? It's 4n plus 1. What it is? Okay, so this is not, this is pi by 2. This is pi by 2 because there are 4 pi by 2, 1 pi by 2, 2 pi by 2, 3, 4 pi by 2. So yeah, that's 1 plus 1 pi by 2, 1 plus 1, yeah. Okay, now if we talk about pi by 2, then that's 42 times pi by 2. And actually it's really easy. In fact, if I just go straight, so this is pi, 2 pi, 3 pi. If I go in that way, it's just odd number of pi, so this will be in this side. So that way it's really easy. I was just trying to complicate and confuse you guys. So this is just odd pi will be here, and that's minus 1. So minus of minus 1 is 1. Minus, this is also odd pi. Yeah, so odd pi means okay, so both of them can't be odd pi. If both of them are odd pi, then both of them are going to be minus 1. Yeah, so then again this is just minus of minus 1, that's a 1. It will be 0. But that will be a problem. Because the answer is 4, not 0. Yeah. What's the square root actually? It's square root. The square root of 21 square is 41, yeah? 1, 2, 2, 4, 4, yeah. If this is 21 pi. Okay, so wait, just a second. I do have solutions. I had done it already. Let me check that. Okay. Okay, it's 0 over here. This one is 0. How did I write pi? This is 0. This is 0. Yeah. So now if it's 0, yeah, cos 0 is 1, so this is minus 1, not 1, not 1. This is minus 1. So this is 2 times 2. That's 4. That's the answer. Let's go to the next problem. This was an easy problem, but I was just trying to confuse you here, and I got confused over in this part. So this is actually easy problem. I don't take it for hard. This is 12. Are there anyone? Are there any person involved? Oh, 7 views and concurrent views are 0. That's fine. But I've got 1, like that's also fine. Now next problem is 13 number. You actually have to enjoy solving these problems. You know, our teacher told that. You actually have to enjoy these problems. If you enjoy, everything will be easy. We had a teacher like Rajendra Dawadi sir, who used to tell a similar thing and always try to make it seem like maths is easy. Though we never did believe him that if it's easy or not, but he told us a lot of those things. Yeah. And now this is just sec square x minus 1. And he actually taught us entire calculus, and we did enjoy that. Now integral of sec square x is tan x, you know. Tan x, and this is just minus x. And already we have the solution. This one is pretty easy problem, you know. Let's go to the next problem. I don't know why do they give this easy problem for the people who are doing bachelors. For bachelors, though, it should have been just left hand thing. Okay, I don't know if you know about this thing. This is just floor function. Yeah. Now floor function actually like rounds down the number. Let's say if we have 2.5, this will just be 2. If you have 2.9 also, this will be 2. If you have 2.1 as well, this will be 2. This just rounds down the number. There are 3 things: rounds down, round up, and round off. So round off we have all been taught. Now there are round up, which is known as ceiling function, and round down, this is known as floor function. Now if it's minus 1.9, this will be minus 2, because less than minus 1.9, that's minus 2. Minus 1 is actually greater than this. Yeah. So we have minus 2. Yeah. Now this is clear. And if we subtract a number with its round down number, the fraction that remains is called fractional part. So if we have 2 minus 2.5, sorry, 2.5 minus 2.5, so for x equals to 2.5, if we just do this, we will have 2.5 minus 2. So 0.5 that remains is called fractional part. Yeah. So this is actually fractional part. Yeah, this one is. And now when there's g function, there's a special way to evaluate this sort of integrals. Now, first of all, it's important to know that. Now in such case, if there are, let's say integral is going from a to b, and if there is a function that involves g, in that case what we do is we try to break these integrals in this way. And there's a benefit as well, I will tell you later. Yeah, we break these integrals basically from in each unit steps. Yeah, and this can be written as sum going from I equals to a to b, an integral from I to I plus 1. Yeah, so it goes from a to a plus 1, a plus 1 to a plus 2, a plus 2 to a plus 3, and so on from b minus 1 to b f of x dx. So this is one of the techniques involved while dealing with fractional parts and z functions. Yeah, the same technique we will apply in this. Okay, so this can be written as sum going from n equals to 0 to 255. There's a reason why I did this. From n to n plus 1. So this makes 0 to 1 plus 1 to 2 plus 2 to 3 plus up to 255 to 256. So the overall integral will be from 0 to 256. And this will be x minus g of x whole square dx. Yeah. Now sum from n equals to 0 to 255, integral from n to n plus 1. Okay, now since this is going from n to n plus 1, yeah, so when 0, this is going from 0 to 1. Yeah, let's say there's a 0.5 in between. In that case, the x will be 0.5, but g of x will be 0. Yeah, so when it's going from n to n plus 1, let's say there's n.5. In that case, this will be x and this will be n itself. So in this interval of integration, this will be x minus n square actually. So that's the benefit of making this kind of manipulation. Now it's easy. Now after this, there's nothing more to do. You can integrate this. This will be x minus n cubed by 3. Going from n to n plus 1. Yeah. And now there's nothing more to do though. Let me do it. From n equals to 0 to 255. At n plus 1, this will be n plus 1 minus 1. This is n cubed by 3. At n, this is n minus n is 0. 0. Yeah. Now this is sum from n equals to 0 to 255 of 1 by 3. So 1 by 3 is added 256 times actually because it starts at 0. Yeah, so if it was from 1, that would be 255 times, but from 0, that is 256 times. So this is the answer, 256 by 3. Yeah. If you check the answer, that's the answer. Now let's go to next problem. This was a good problem for you to learn, but if you know it already, it's a good problem for practice, and if you don't know, it's a good problem to learn. Now this problem will involve integration by parts, and there's also a good technique for evaluating integration by parts, which is known as DI method. I will let you know of that as well. First of all, it's necessary to let this as x. That gives us y to the power 4 is x, and then 4y cube dy is dx. This is e to the power y, and dx is 4y cube dy. This is 4 times integral of e to the power y y cube dy. Now for this, it involves integration by parts actually. This should be made u, this should be made v, and you need to do it 3 times or more. So in that case, we can actually use a DI method. So if we have to integrate e to the power y times y cube dx, yeah, there's an space, and first of all there's a minus sign, and I want you to explore like how this works from the integration by parts itself. It's not that hard. So we just write alternating signs first. Now, first of all, write this as it is, e to the power y. Now integrate. sorry, differentiate this. We are basically integrating this and differentiating this. You can choose any one of them, but integrating this will not simplify the problem. So let's differentiate this. Yeah, but sorry, okay, the one that should be differentiated, that should be written at the beginning. I'm sorry for that. Okay, fine. So basically, if you use integration by parts also, you will have y cube as it is, yeah? Then you will integrate this. Now, so it goes on. So integration is in the second. First of all, there is the thing that will be differentiated, yeah? So the same approach. So that's why this will be first of all, and this will be in the second. And this is differentiated, this is integrated. But at first, this is not differentiated, yeah? At first, this is as it is. And this one is integrated. And again, integration gives e to the power y itself. Minus. Now only this is differentiated. So minus 3y square. And this is integrated, e to the power y. This is differentiated. This is integrated. This is differentiated. This is integrated. After this, it will just give 0 if you differentiate this. So this is the limit. And this is the answer actually. Now if you multiply by 4, we will get 4y cube e to the power y minus 12y square e to the power. Now let me also take e to the power y common. That will make us life simpler. E to the power y common. 4y cube minus 12y square plus 24y minus 24 plus c. And now let's substitute y as x to the power 1 by 4. E to the power x to the power 1 by 4. 4 times x to the power 3 by 4 minus 12 times x to the power 1 by 2 plus 24 times x to the power 1 by 4 minus 24 plus c. This is the answer. E to the power x to the power 1 by 4, 4 times x to the power 3 by 4 minus 2 x to the power 2 minus 2 minus 24. Yeah, that's the answer. Let's go to next problem. Problem number 26. Sorry, 16. This one is not a hard problem. I think. I don't really know though how hard is it or how easy is it, but let's try. So this is cos x, but here we have cos x by sin x. Yeah. And then dx. Now this will be cos square x by sin x dx. Now you can use the 1 minus sin square x in place of cos square x dx. Then it will be integral of cosec x, yeah, minus, is that sin x? Is that sin x? If it is sin x, then that will be really easy. But I don't really think it is that easy. So let me check my source. I don't think it will be that easy, you know. Okay, so it's actually easy. It's actually easy, in fact. So now integral of cosec x, that is ln of cosec x minus cot x, but also there's an other form, which is ln of tan x by 2. Yeah. But it's, yeah, it is now fine. And the integral of minus sin x is just cos x plus cos x. Let's see. Now ln of tan x by 2, it's ln of sin x by 2 by cos x by 2. So that gives us ln of sin x by 2 minus ln of cos x by 2 plus cos x plus c. That's the answer. Yeah, I actually did this by looking the problem itself. Yeah, so you can grab this. I don't think it's that hard. Yeah, so sometimes we need to be tricky. Sometimes we need to be tricky. Not tricky though. Be cool, not cool as well. I don't know the word, but I was that person right now because I saw the answer it first and then told you the formula. That's a really nice way to like make yourself somehow genius. Yeah. Now for this problem, we have log x square plus 2 log x dx. Now for this problem, this is actually a derivative of some function, and I do know that because I have already done it. This is just the derivative of x log x square. But to find out, you can use integration by parts in the first function. So if you use integration by parts with 1 as b, you will have log x square, and then integral of 1 is x minus integral of derivative of log square is 2 log x times 1 by x, and the integral of 1 is x. Yeah, and then we have the plus integral of 2 log x over here dx. Now this cancels out. Yeah, and now these two are the actual same integral, so these also cancel out. We have x log x whole square now remaining, and then plus c. This is the answer. Yeah, that's the answer. Let's go to next problems. These problems are not that hard, These problems are actually easy, not too easy, but somehow easy, and we are enjoying doing these problems. For this problem, what we can do is we can let y as x square. That gives us dy equals to 2x dx. And we will have dy by 2 equals to x dx. And then this will be y dy by 2 by 1 plus y. Now this can be made as y plus 1 minus 1 dy. Now this will be 1 by 2. Integral of 1 is y minus integral is ln of y plus 1 plus c. Now y is x square. So we have 1 by 2 x square minus ln of 1 plus x square plus c. This is the answer. If you have to check it, 1 by 2, let me see the answer again. X square by 2 minus ln 1 plus x square by 2. Yeah, that's the answer. Let's go to next problem. Are you feeling these problems hard? If there's anyone. Hi sir, hello sir, great work. Hi, thanks for watching. And are you feeling these problems hard? I don't think they are hard, yeah. Let me just reply. Thanks for the appreciation. And do keep learning. Learning is the weapon to change the world. Yeah. Now also next problem. Next problem is this one. This problem is not that hard, I guess. I don't think this would be hard. So we have 1 plus 1 minus 2x plus x square. Yeah. Now you should notice that this is actually the 1 plus, this is 1 minus x whole square. Yeah. Now, okay, for this, so this is actually in the form of 1 by 1 plus x square dx. In that case, our integral will be tan inverse x plus c. Same is the case here. But if there's a square x square, if it's a square x square, okay, so I don't mean that actually. If it's x square plus a square, it will be 1 by a over here. Yeah. And tan x by a over here, but we don't have that a square, so let it be like this. Now let's not make sense any. Now for this one, this is just tan inverse 1 minus x. But since there's a coefficient minus 1 for x, we'll divide a minus 1 and then write plus c. And this is the answer. You see? There's minus sign. Now the other way would also be to do, we can also do it x minus 1 whole square plus 1. Yeah. In that case, it will just be tan inverse x minus 1 plus c. Yeah. Actually, tan inverse is odd function, so if we take minus common, this will just be minus. So we can do it anyways. These are not the hard problems. We can do it anyway. Let's go at 20. 20 number seems to be a long problem. Yeah. 20 number seems to be a long problem. But it's not a hard problem because in 2013 there were only easy problems, you know. In 2013 there were only easy problems. Okay. Now for this problem, we have sin x ln of sin x dx. It seems like we can use integration by parts using this as u, this as b. We have ln sin x. Integral is minus cos x. Yeah. Minus integral of derivative of this is 1 by sin x times cos x. Integral of this function is minus cos x dx, isn't it? Yeah. Now this is minus cos x ln sin x. In the other function, we have done that already. The other function is plus cos square x by sin x. We have done that already. And the integral that we already did was, let us check the answer from the website itself. Cos x plus ln, what's that? Cos x plus ln tan x by 2. So this is cos x plus ln tan x by 2. And this is minus cos x ln sin x. And plus c, that's the answer. Yeah. Is that it? Yeah, that is. Let me check the answer. Cos x plus ln tan x by 2 minus cos x ln sin x. Yeah, that's the answer. Let's go to the next problem. 21. This problem. For this, you can let y as x square. You can let y as x square. That gives us dy equals to 2x dx. And that gives us dy by 2 equals to x dx. Now we will have x dx as dy by 2. And that will be 1 minus y square. So we will have 1 by 2. Now integral of this is 1 by 2. A is this 1 square, so 1 is a. Ln of a plus x by a minus x plus c. So integral is 1 by 4 ln of y is x square. So 1 plus x square by 1 minus x square plus c. So this is the answer. 1 by 4 ln 1 plus x square by 1 minus x square plus c. Yeah, this is the answer. You can see over here. Now let's go to the next problem. I think you are enjoying these problems. Yeah, now we just have few more problems to finish. This was already done. This we had already done. Okay, so it asked indefinite integral this time. Previously, it asked us definite integral. Now it asks us indefinite integral. For that, we have a formula though. So if we take out root 3, we have root under 4 minus x square. Now we can directly use the formula that integral of, if you don't want to use formula, you can use trigonometric substitution. That will also give answer. You can use x as 2 sine theta and then solve. But I will use formula over here. That is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus c. This is the formula actually. But why does it seem like this will not work type of thing? X by 2 root under a plus a square by 2 sine inverse x by a. Let me check, like, why is it not working? I mean, it seems like it will not work. Oh, it will work. The by 2 is taken out common, so that's why it can be 4 here. Now, fine. Now, root 3, that is x by 2. So, x by 2 root under 4 minus x square plus a square. A is 2. A square by 2 sine inverse x by 2 plus c. Now by 2 is taken common, so that's why we will have root 3 by 2 x root 4 minus x square plus 4 sine inverse x by a plus c. This is the answer. That's the answer. Let's go to the next problem. This one. Okay. For this problem, we can first differentiate these things as like this. We can not differentiate, I just mean group them as like this, like x, 10x, dx. Now if you group them like this, you will see that if you let y as sec x, this will just be dy, and this will be y square minus 1. Yeah, because sec theta minus 1 is tan theta, yeah. So this will be y to the power 4 y square minus 1 times dy. And this gives us y to the power 6 minus y to the power 4 dy. And answer will be y to the power 7 by 7 minus y to the power 5 by 5 plus c. Now y is sec x. So we will have sec to the power 7x by 7 minus sec to the power 5x by 5 plus c. This is the answer. And to get this answer, you can basically take sec to the power 5x by 35 common, and that gives us 5 times sec square x minus 7 plus c. That's the answer. Plus c. Yeah. Let's go to the next problem now. Problem number 24. We are nearly at the end of these problems, 25 problems. This problem were not that hard, so I wasn't confused like in the previous sessions. In previous sessions, like in one problem, I was so much confused that I saw my copy 3 times or so. That was a real mess. Yeah. Okay. Now from pi by 4 or to pi by 4. This can be written as 1 plus sine x by 1 minus sine square x, that's cos square x. Actually, I multiplied numerator and denominator by 1 plus sine x. Yeah, I did this thing, so that's why I got the following expressions dx. Now this will be integral from minus pi by 4 to pi by 4 sec square x plus sec x tan x dx. Now that will be tan x plus sec x, going from minus pi by 4 to pi by 4. Tan pi by 4 is 1, sec pi by 4 is root 2 minus tan of minus pi by 4 is What is it? Minus 1. Sec minus pi by 4 is root 2. So this will be 1 plus 1, that's 2. 2 is the answer. Yeah, we have that here as well. Let's go to the next problem. Problem number 25. This problem, my answer will be easier than the what is given over here, I'll find an easier answer because I have some standard tools than the problem proposer had. Basically, I will directly use a formula. This is actually a standard formula. If we have 1 by x square minus a square, this is actually 1 by a sec inverse x by a plus c. Now, why is this the answer? You can just substitute x as a sec as x, and then if you a sec theta. If you do that, you will see that you will have a sec theta, and then you will also have a tan theta over here. And in numerator, you will have a sec theta, tan theta, d theta. Tan theta, sec theta, a. So 1 by a theta plus c. And theta is sec inverse x by a. So 1 by a sec inverse x by a plus c. This is the answer. And now our a is actually root 2 over here because it should be a square, yeah. So 1 by root 2 sec inverse x by root 2 plus c. Now this is as by b, so this is as, this is b, isn't it? If this is as this b, this is actually p by b, isn't it? So over here, no, actually these two are not matching. I seem to have some problem. This solution seems to have some problem then. 6 square theta minus 1 times theta. A sec theta. No, I don't really have any problem though. But why are these two not giving the same answer? Let me check my copy again. Let's check my copy again. So basically, in my copy as well, I'm not getting that answer though. Okay, I think I can get this answer somehow. Okay, so see here. Over here we have minus sign as well. So that is what giving us the trouble. Since there's minus sign, we can write this as minus tan inverse root 2 by root under x square minus 2. Yeah. And now, since there's a c, we can just add arbitrary constant pi by 2. That doesn't matter, and make this constant as cdans. Now pi by 2 minus tan inverse something is actually cot inverse something. So that is cot inverse root 2 by root under x square minus 2 by root 2 plus cdans. Now cot inverse something is tan inverse of 1 by something. So that will be tan inverse root under x square minus 2 by root 2 by root 2 plus c. Now it matches. So this is P, this is B. Yeah, our B is same now. So since this is H and B, if we take it into P and B, we can have tan inverse. So for this H, our P will be root under H square minus B square. And that will be H is X. So X square, B square is 2, minus 2. So we will have tan inverse. In tan, that we should have P by B. P is root under X square minus 2. B is root 2 plus C. So you see, we got the same answer. Yeah, so this is same as this one, this is same as this one, and the original answer. So in this way, we have solved all the 25 problems. And I hope you enjoy the solutions and how I made these manipulations. Yeah, I think we spent a pretty good time solving these problems. Yeah, there's a long list of solutions. It seems like a ladder of solutions. And it's pretty nice to watch the work that you have done, that I have done. What is the time now? Okay, so it's 1 hour already. Yeah, I hope you enjoyed these problems and I hope it's helpful for you in practicing for integration